Let's solve this one using round robin. So first of all, let's maintain the queue and the Gantt chart. So the queue contains what is the first process that has arrived. If you look at the arrival times, the first process has arrived at 1 and that is P4. Therefore P4 will be initially in the queue, right? And the Gantt chart, even though you are going to start with 0, we have to be idle till 1. The reason is no process is available till 1. And now at at the time period 1, I am going to choose the only available process, which is P4 from the queue, and schedule it P4, right? And how long is it going to execute? If you watch it, it is going to execute for one time quantum, which is 3 units. Therefore 1 plus 3 is 4, so it can execute till 4. Now P4 has executed for 3 units, therefore remaining time is 6, isn't it? And now by this time 4, add all the processes which are arrived, right? So by this time 4, what are the other processes which have arrived? At time 2, P5 has arrived, and at time 3, P3 has arrived, and at time 4, P2 has arrived, right? Therefore in these 3 units of time, 3 more new processes got added. Always remember that after executing a process for time quantum, and it is before doing anything else, you try to add first the process which have arrived during that time, and then you try to put that process back. Therefore put the process P4 back, right? And now what is remaining? P5, P3, this one, right? So what is the next process that has to be scheduled according to the queue? P5. If I schedule P5, how long should I run it? Just check P5. P5 needs only 2 units of time, but I have a facility to run for 3 units, but anyway I am going to run it for only 2 because it needs only 2. Therefore once I run it, it is going to execute to completion. Now the time is 6, right? Therefore by the time 6, see what are the processes which have arrived. So P1 has arrived at time equal to 5 and P6 has arrived at time equal to 6. Therefore all the processes have arrived. See this, 1, 2, 3, 4, 5, 6. All the processes have arrived by now. And now should I add P5 back to the queue? No need, because P5 has already run to its completion. So no need to add P5 to the queue. And next one that has to be scheduled is P3. Now just see the time for P3. So burst time for P3 is 7, isn't it? But then you are not going to run P3 till for 7 units. You are going to run it only for 3 units, which means till 9 I am going to run it. So it is going to remain as 4. And now by the time 9, everything has arrived, so you need not worry about any new process. And here you can stop worrying about the new process, and you should decide only whether the present process has to be added back to the queue or not. Should it be added? Yes, because P3 needs even more time. How much? 4 units. Therefore add it back. P3 is going to be back here, right? And now after this, the next one is P2. So I am going to take P2, and how much time does P2 require? 6 units. Therefore I run it for 3 units because I have only that much amount of time, quantum time. Therefore it is going to be 3 now, right? And now should I add P2 back to the queue? Yes, because P2 need to be executed further 3 units. Therefore add P2 back to the queue. And what is next one? P4. I am going to schedule P4, right? And how long are you going to execute P4? So if you watch P4, it requires 6 units of time. Therefore I am going to execute it for 3 units. So it is 15, right? And it even needs 3 more units further. Therefore I should again put P4 back, right? And next one that has to be scheduled is P1. Therefore P1 is chosen. And how much time does P1 need? P1 needs 5 units, but I can execute only for 3 units. I am going to execute it, and therefore it requires 2 units of time further. So I am going to add it at the end of the queue, so that later at some point we can take it and schedule it. And next one is P6. Therefore P6 is going to be scheduled here, right? So look at the need of P6. It exactly needs 3 units, so I am going to run it for 3 units, so it will run till completion, which means till 21 it will run till completion. And after that you don't need to add P6 back because it is not required, isn't it? It got completed. And next one is P3. Now I am going to take P3 out. If I take P3, it requires 4 more units, but then I can run only for 3 more units. Therefore remaining time will be 1. So if I run till 24, it has to be run for 1 more unit. Therefore I am going to add it back to the queue. And next one which is going to be executed is P2. Fine. And now if you look at P2, P2 requires P2 need to be run for only 3 units. So run it for 3 units, it will run till completion, which means by 27 it is going to be completed and you need not add it back. Okay, P2 need not be added back. And next one is P4, right? So P4 will be scheduled here, and what is the P4 is here, and what is the requirement? Only 3 units, therefore it can run till completion if I run it till 30. So P4 need not be added back. Next one is P1. P1 will be scheduled and P1 need to be executed for only 2 units, therefore you can execute it for till 32 and it will become 0. Once it becomes 0, you can actually need not add it back. So P1 need not be added back. Next one is P3. P3 is scheduled, and if you watch P3, it needs only 1 unit of time. Run it, it will run till completion. 33, you need not add it back. Got it? So this is how this entire procedure is. And now let's see completion time, turnaround time and waiting time, all these times. So first one is, let's talk about the completion time. At what time they got completed? Completion time, right? So come from the ending. P1 got completed at 32, therefore completion time of P1 is 32, and then P2 got completed at 27, so completion time is 27, and P3 got completed at 33, and P4 got completed at 30, and P5 got completed at 6, right? And P6 got completed at 21, and after that you can find out turnaround time. Turnaround time is difference between completion time and arrival time. So what is it? 27. What is it? 23. What is this? 30. 29. 4. What is it? 6. 15. Right? And now after finding out turnaround time, you can find out the waiting time. So what is the waiting time? Turnaround time minus burst time. So how much is this? 22, 17, 23, 22, and then 12, right? And that is how you can find out the waiting time. So this is the turnaround time and this is the waiting time. You can find out average of these two, dividing it with 6, add them and divide it with 6. Now let's see response time. Response time is nothing but once after the process gets arrived, once the process becomes available, which means if it is arriving, then after how much time did you schedule it for the first time, that is the response time, or a process is going to respond to you once you schedule it. Therefore the first response is nothing but the response time. That depends on when you have actually processed it. I mean, that depends on when you have actually scheduled it, right, for the first time. Now see this, how can I find out the this response time is? Now check this one for each one. When did P1 got scheduled for the first time? At the time 15. When did it arrive? It arrived at 5. Therefore 15 minus 5 is 10. So that is the response time for P1. And what about P2? When did P2 got scheduled for the first time? So now you are supposed to come from the right. Whenever you want to see the first time, you are supposed to come from the left hand side. Whenever you want to see the completion time, you are supposed to come from the right hand side. Now look at P2. Now you got P2 for the first time at 9, isn't it? So at 9 it got for the first time, it got scheduled for the first time, but when did it arrive? It arrived at 4. Therefore 9 minus 4 is 5. That is the response time for P2. And what about the response time for P3? If you watch the response time for P3, it got scheduled as 6, but it arrived at 3. Therefore its response time is 3. And what about P4? It got scheduled at 1, but it arrived at 1. Therefore response time is 0, which means it responded immediately, right? And then what about P5? It got scheduled at 4, but it arrived at 2. Therefore its response time is 2. And what about P6? It got scheduled for the first time at 18, but it arrived at 6. Therefore its response time is 12, right? And now you can find out the average response time. What do you think will be the effect of quantum time on response time? The process will have to wait for a long time if it for the response, or a process will be scheduled after a long time in case if the time quantum is higher, and in case if the time quantum is lower, the process will get scheduled immediate, I mean as early as possible, right? So what I could say is, as the time quantum as it increases, one is context switching increases and second is response time increases, which means it will take lot of time for the process to respond, right? Oh, if the time quantum increases, context switching actually decreases because we need not do lot of context switches, and as the time quantum decreases, context switching they increases but the response time will decrease, right? Therefore higher time quantum is better in terms of context switching, and lower time quantums are better in terms of this response time. So depending on your need, you are going to choose it. If you want all your process to be very interactive, then go with the lower process, this response time. And one interesting thing is, what happens if time quantum is infinity, which means if I allow any process that has been picked up to run till its completion. Time quantum is infinity means a process can run forever, but then it cannot run forever, it will run only for its burst time. So how does it behave now? Once you pick a process for scheduling, once you schedule it, it will run till its completion. Now how are you going to pick each process? Depending on the arrival time, right? Therefore whenever time quantum becomes infinity, this round robin will slowly become this first come first served. As you keep on increasing the time quantum, round robin will slowly approach the first come first served, and whenever the time quantum is sufficiently large, then round robin will become first come first served completely. Got it?